Aloha, my name is Robert from Neapapakahana, and welcome to the Online Professional Development for Module 11 of the Canoe project. To begin, let's go onto our website, www.stemd2.com, and after you logged in, let's go on to Students, and let's build a canoe. Module 11 is in Unit 5 of the Go Math book, so let's go down to Unit 5. Here we can read a story related to Unit 5, or we can go over here and watch an accompanying video. Whenever you're ready, let's go down to Module 11. Here is a list of activities for Module 11, which is about angle relationships in parallel lines and triangles. The first activity that we'll be talking about is Canoe 11.2.1. In this activity, we will be learning about how Kumu'ahi and Kumu'aku catch fish in this bay that is near their house. The way they catch fish here is they first paddle out away from their house towards the edge of the mouth of the bay. So Kumu'ahu and Kumu'ahi paddle out from here to the edge. When they reach the edge, they grab a big net and they pull it all the way back to shore. This is how they are able to catch a lot of fish. In this activity, we will take a deeper look into this strategy and learn more about the angle theorems for triangles. If we look carefully, we can see that Kumu'ahi and Kumu'ahu, they paddle along triangular paths. So one goes around here, and the other path goes around here. Below is a diagram showing the measure of some of the angles that are formed by these two paths. We begin this activity by finding the measure of the missing angles. As we can see, these three angles form a triangle, so we can use the triangle sum theorem to figure out the measure of angle A. These three angles form a different triangle, so we can use the triangle sum theorem again to figure out the measure of angle B. After we have the measures of angles A and B, we can find the measure of angle C because A, B, and C are supplementary. Now let's think about how certain pairs of angles are related to other pairs of angles. In particular, let's take a look at angles A and C. The angles A and C, the sum of the angles A and C are equivalent to the sum of what other two angles? If we look closely, we can see that the sum of angles A and C is the external angle of this triangle. Therefore, we can apply the external angle theorem to see that angles A and C is equals to 90 degrees plus 42 degrees. In other words, 132 degrees. We can also use the external angle theorem to see that the angles B and C are equivalent to the sum of this angle and that angle. We designed the last couple of questions to help the students see that there is a close relationship between the external angle theorem and the triangle sum theorem. In particular, we hope that some students can see that these two angles are equivalent to these two angles. And this is because both pairs are supplementary to the angle B. So these three angles are supplementary, and these three angles are supplementary. We conclude this activity by taking some time to talk about climate change. Climate change can drastically affect our island way of life by changing our landscape. So here's a picture of the bay before climate change, and here's a picture of the bay after the beach has eroded due to climate change. With this new picture, we ask the students again to use the theorems that they know in order to show the relationships between different pairs of angles. And then we ask the students an open-ended question. As we can see here, this side of the coast has eroded away. How will erosion and climate change affect Kumu'ahi and Kumu'ahu's way of life? Please have your students share with the class and on the comments section below. That's it for this activity. Please pause the video and take some time to review and reflect on it. Let us know how you can use this activity in your classroom. Welcome back. The next activity that we'll be talking about is Canoe 11.3.1. In this activity, Manu is making a model of the Hokulea, which is this amazing voyaging canoe. Right now, Manu is trying to make a pe'a, or a sail, for his model of the Hokulea. He wants to make sure the angles are exactly perfect. Luckily, he got a sketch from a builder that worked on the Hokulea. Unfortunately, it is missing one angle, but we can use the triangle sum theorem to figure it out. Here are two sketches that Manu made on his own. We can use that theorem again to figure out the missing angles. After we found the missing angle, we can use the angle-angle similarity to figure out which of these sketches best represent the Hokulea's sail. Now we should have the right shape for Manu's pe'a, but we need to figure out the correct size as well. So in the final question, we have the real size of the Hokulea, and we have the size of Manu's model. With this information, let's try to see if we can make a pe'a that is appropriate size for Manu's model. That's it for this activity. Please pause the video and review and reflect on it. Aloha! The next activity that we'll be looking at is Canoe 11.c.1. In this activity, we will be looking at a simplified version of the star compass. The star compass is a system that Pacific Islanders have used in order to navigate the Pacific Ocean. In this system, we have the canoe and the navigators at the center, and then we also have the horizon broken up into different sections called houses. Throughout their journey, the islanders will see the winds and the waves come at them from some houses and then leave in other houses. They will also see the moon, the stars, and the planets come up into the sky from one of the houses in the horizon and then exit again through a different house. On every voyage, there is a master navigator who is able to keep track of all of this information. With this information, the navigator can guide everyone safely across the huge Pacific Ocean to their destination. In this activity, we will try to figure out what direction we're going using just the sunset and the star compass. Over here is a map of the Hawaiian Islands, along with 4 canoes, A, B, C, and D. Canoe A is over here, and they are heading straight towards the Big Island. If we compare this diagram for Canoe A and this diagram for Canoe B, we can see that this angle and this angle are supplementary. If we rotate this to line up the sunsets, then we can see that Canoe A and Canoe B are going in opposite directions. If we rotate this to line up the sunsets, then we can see that Canoe A and Canoe B are going in opposite directions. So if Canoe A is over here and heading straight towards the Big Island, then Canoe B must be going in this direction, away from the Big Island. Now let's take a look at canoes C and D. They have the same diagram, so they must be going in the same direction. Here's the direction of the sunset. The sun always sets in the west, so this must be pointing south. That means that canoes C and D are going south. So if we look at this diagram, we can see that C is going towards the Big Island and D is going away from the Big Island. Students with navigational skills might have an advantage in this activity. We hope that they take this opportunity to help out their classmates and develop their confidence in mathematics. Well, that's it for Module 11. We'll see you again for Module 12.